In this problem, we will perform a subtraction using 8-bit signed 2's complement arithmetic. Important concepts include signed binary numbers, 2's complement format, binary weights, and the fact that a minus b can be written as a plus negated b. Now the problem statement asks us to perform the subtraction 33 minus 37 using 8-bit signed 2's complement arithmetic. Now it turns out that digital systems routinely handle subtraction like this. If we want the difference of two values a and b, the subtraction is actually implemented as a plus negated b. It turns out that this method is actually more efficient in hardware than setting up a distinct adder and a distinct subtractor circuit. Now we can negate a signed number by first inverting the bit values and then adding 1. Now let's start working through the details of this problem. Let's first begin by writing 33 base 10 as an 8-bit signed number in 2's complement format. Now for an 8-bit number, we write down 8 binary weights, and since we're dealing with signed 2's complement format, we use a negative weight for the most significant bit. That's right here on the left side. So it's the largest weight, and it also carries the negative sign. Now we do not need the negative weight to build up positive 33. However, we do need 31 and 1. When those are added together, we have 33. Now let's first begin by writing down the representation for positive 37. And at this point it's probably a good idea to clearly state that these are positive values. So I would need the weights 32, 4, and 1. And when added together, that's 37. Now we want to form the difference of 33 and 37, so I will negate this value on the bottom. So we negate the value by inverting the bits and then adding 1. Let's do the invert bits part. So zeros go to ones, ones go to zeros. And in this case, adding 1 is very simple. We didn't have to worry about any carries from one step to the next. Alright, let me take that result and swap that in the bottom position here. So now we have minus 37. And at this point, we add these values. So we say we're doing 33 plus negated 37. Here we have 1 plus 1 is 0 with a carry. 1 plus 1 is 0 with a carry. There's 1. And looks like no more carries for this problem or for this sum. And this binary pattern is actually the result that we seek. Now let's just go ahead and check this by converting it back to decimal and make sure that it gives the expected result. Looks like we need most of the weights. We would have minus 128 plus a fair number of positive weights. All of the positive weights sum to the value 124. That leaves us with a result of minus 4 base 10. And sure enough, 33 minus 37 would give us minus 4. All right, briefly, let's take a look at the overall approach. Fundamentally, we recognize that subtraction a minus b is handled as an addition, a plus negated b. We then wrote the values a and b as signed binary values in 2's complement format. We negated b by flipping the bit values and adding 1. We then added a and its negated b value to obtain the difference, and then converted the difference to decimal and compared it with that expected result of negative 4.